In this section, in this week, we're going to be talking about momentum. What is momentum? Well, an overview of the things we're going to cover. We're going to cover momentum. We're going to cover impulse, conservation of momentum, elastic and inelastic collisions. The units that are going to be involved in all of this, of course, for elastic and inelastic collisions, will also be energy, so those are joules. But we don't have a fundamental unit for momentum, or we don't have a unit just for momentum. So momentum, the units are kilogram meter per second. So let's start looking into our first set of equations. Momentum is all about mass in motion. So variables involved are mass, velocity, and we use the symbol p, a lowercase p, for momentum of an object. And again, the units are kilogram meters per second. It's a very simple, straightforward equation. Momentum of an object is its mass times its velocity. Now, momentum is a vector, and that means it has a direction. But we're only going to be doing momentum in a straight line. You're not going to have to worry about angles. You're not going to have to worry about momentum in two different directions at all. Momentum in the positive x direction is going to be positive because velocity in the positive x direction is positive. And momentum in the negative x direction is going to be negative because velocity in the negative x direction is negative. Basically, left to right, if it's moving that way, it's positive momentum. And if it's moving that way, it's negative momentum. Momentum adds, and you have to take direction into account. So if I have one object going this way with that much momentum and another object going that way with that much momentum, these cancel each other out and you have zero momentum. Impulse is simply a change in momentum. And so the variables involved in impulse, well, there's momentum, of course. There's force, which is in newtons. There's change in time, or the time over which a force is applied, that we call delta t. That's in seconds. There's a change in momentum, delta p, and that's going to be kilogram meters per second. And then there's the symbol we use for impulse itself, which is J. J is an impulse, but it has the exact same units as momentum because J is just the change in momentum. So J is delta P. Delta means change in, so J is change in momentum. A change in momentum is due to a force applied over some period of time. So we can also write J is a force times the amount of time that it takes to apply that force. Momentum is our second conserved quantity. All right, remember energy was our first. Well, momentum is also a conserved quantity, and we have different notation we're going to be introducing in here. P1 is one object, P2 is another object, right? Because with momentum, you have to keep the objects separate or track them separately because they don't add simply. You have to take direction into account. So P1 plus P2, the momentum of objects 1 and 2 before collision, P1 prime plus P2 prime, the momentum of the objects after collision. And of course, because we're dealing with momentum, we have mass and velocity. So total momentum before collision, P, is P1 plus P2, which is just M1V1 plus M2V2. Total momentum after a collision, P prime, is P1 prime plus P2 prime, which is just M1V1 prime plus M2V2 prime. And the prime is to say this velocity, V1 prime, is not necessarily the same as that velocity, V1. It's simply the velocity of mass 1 after the collision, just as this is simply the velocity of mass 2 after the collision, and it may be and usually is different from the velocity before the collision. Momentum is conserved in a collision, and so P is P1, P prime, M1 V1 plus M2 V2 is M1 V1 prime plus M2 V2 prime. There are two major types of collision, elastic and inelastic. Collisions don't always conserve energy, even though they conserve momentum. And so the variables we're going to be looking at in this, we're going to be mass, velocity, and kinetic energy. So elastic collisions conserve not just momentum, but kinetic energy too. So if you were going to look at an elastic collision, the kinetic energy before the collision and the kinetic energy after the collision are equal, which boils down to this big equation here, 1/2 m1v1 squared plus 1/2 m2v2 squared plus equals 1/2 e1 m1 v1 prime squared plus 1/2 m2 v2 prime squared. This is conservation of energy with no change in potential energy and the work due to non-conservative forces equal to 0. The biggest place kinetic energy is usually not conserved is when non-conservative forces are not 0. And so those are inelastic collisions. Ke does not equal Ke prime. Although the momentum conservation still holds. So this equation for momentum conservation will still hold even when the kinetic energy is not constant. All right, that's it for this this week, and hopefully you'll have fun working through the problems and learn a lot.